Okay, hi there. I'm Hao, and this is just another video of me solving the numerical problem. So today we need to delete a node in a binary tree. So what does it mean? It means the tree is sorted, right? So hopefully we can do it in log of n, right? Like O of height, the height of the tree. Okay. Um, delete the node even for the key, right? Return the root node reference. Okay. So search for the node and return. Okay, yeah, really straightforward. So how do we do this? So 5, 3, and then 6, and then 7. So let's say we want to delete node 3 here, right? So at any point in time, right, we can split the input in half, right? Because it is a binary search tree. If our target is 3, our key is 3, right? We just comparing and then divide our input in half. But eventually, because 3 is smaller than 5, so we go left, right? Eventually, we will find 3. Okay, 3 is here. So how do we delete 3? So if 3 have no children, we just return no, right? Easy, right? And then, so the first case, right? No children, we return no, right? So the second case is one child. What do we do? So that's like this is 3, and the 3 have one child, 2, right? If it's only have one child, right? It does no. Then we're just gonna return. So we are at 3 now. We can just return node number 2, right? We can just get rid of that and put the connector 2 here, right? And vice versa, uh, if the left node is no, right, then we return the right, right? So we set the node here, right, dot left is equal to 4, right? Get rid of this, right? So if the left is no, we return the right, and if the right is no, we return the left, right? So one child, we do two things, right? Left is no, we return right, right? And then right is no, we return left, right? Okay. So the third case, what is the third case? Let me change color here. Uh, first case. The first case is two children, right? Two children. So let's say we have 2 and 4 here. So how do we delete 3 if we had 2 children? So remember the binary search tree invariant is that the parent has to be greater than the left child, everything on the left branch, and it has to be smaller than the right child and everything on the right subtree, right? So um, we can, okay, let me just give it a few more notes here, just so a little bit easier to visualize. Uh, 0.5, like hundreds, whatever. Right. Say this is, yes, good enough. Okay, so we have, okay, do this, just 2.5. Okay, so we have two options here. We can either replace the target node with the largest node on the left, which is 2.5 here, right? So if it is 2.5, right, it is valid, right? Because 2.5 is larger than 1 and 2, but smaller than 4, right? Or we can replace it with the smallest node on the right? Which is 4 here. 4, right? 4 is valid because 4 is greater than the whole thing here, right? Um, so if we have like 4.5, and then 3.5, right? So we can replace it with the smallest node on the right side, on the right subtree, right? This subtree, right? So it is either the smallest node on the right side, which is 3.5, right? 3.5 here is valid because 3.5 is smaller than 4, smaller than 4.5, right? And 3.5 is larger than 2, 1, and 2.5, right? So it is valid, right? Or we can replace it with the largest node on the left side, right? Which is 2.5 here, right? 2.5 is valid, right? Because 2.5 is larger than 1 and 2, but it's smaller than 4, 3.5, and 4.5, right? So if we have two child, right, then we can either do the two things, right? Uh, replace it with the, let me just erase this. Replace it with the uh, largest node on the left, right? Or replace it with the smallest node on the right to keep the BST invariant, right? So makes sense, right? And then after we replace the target node with this value, what do we have to do? We need to delete the values that being replaced, right? Which is like the largest values on the left or the smallest value on the right, right? We just have to uh delete that. And how do we delete that? Well, we already have a function to do that, right? So we just have to call the function to do it. Okay. So that is the general algorithm there. We have like three cases. So let's close this up. So if we don't have a root, we return null, right? And then if the root dot var is less than the key, and we move to the right side, right? So root dot right is equal to delete node of root dot right and then key, right? We want to return the root at the end, right? Else if the root dot var is greater than the key, and we want to move left, right? Move left. So right dot left, root dot left equals to delete node of root dot left passing in the key, else, which means we already found the target, right? So there's three cases. So if there's no left children and there's no right children, we return no. Return no. Return no, right? And if we don't have the left file, we return the right. And then if we don't have the right, we return the left, right? So if this line doesn't return, right, which mean which mean either the left or the right is valid or both, right? And if we don't have the left, we return the right. If we don't have the right, we just return the left child, right? We replace the current value with the left subtree or the right subtree, right? And if we get to line 26, which means that we are in the third case now, the target node have two children, right? So we have to let's say we want to find the largest node on the left, right? So we can do max node equal to the largest node on the left, right? So we can start with the left and y max node dot right. We want to do max node dot right. Max node equal to max node dot right, right? We keep because the largest node on the left will be toward the, so we just keep iterating right until we reach the end. Okay, and we want to re, uh, replace the root value, which is the node that we want to delete. We replace that node value with the logic to maximum dot value, and then we have to delete the largest node on the left. So root.left equal to delete node, right? Passing in the root.left, and the value will just be the max node of value. Right? Okay, so if we don't have children, we return no. If we have one child, right, we return the other one, right? If the other one is no. If we have two children, then we find the largest node on the left side, right? So we start from the left subtree, root.left, which means we start from the left subtree. And then we just keep going to the right until we reach the bottom, because we know at the most right side is the node will be the largest, right? And then we set the value of that largest node to the root, right? Which is the target, the node, the node that we want to delete. And then we need to delete the node that way we just swap, right? So we just have to call the method here and pass in the root.left. So remember that we have to pass in the root.left here, not the root, right? Because like right now, let's say we replace this value with 2, right? Which means our tree right now have 2 nodes with the same value. If we pass in the root, which is 3 here, then this node will get deleted. But we want this node to be deleted, right? So instead of passing the root, we pass in the root.left, right? Which is the left subtree here. So that is guarantee that this value will be deleted, right? And we were able to do it in log of n. All right, so let's give it a try. Okay. Okay, so it is a constant, right? If we want to make change it, we need to make it become a net variable. So let's try again. And it worked. Submit. And thank you for watching.